recording. So one more time, I'm going to share this screen. So now we're going to start on section 4.4. No, 4.5, right? Complex rational expression. So it's like a complex fraction. So we just gotta basically turning the division into the multiplication. So I'm going to show you one of the examples here. And I'm going to show you all the details, like how we're dealing with these complex fractions. Okay, so something like this, right? So this is a typical complex fraction. So let me clean screen first. So typically, whenever we have a complex fraction, first step is turning the basically rationalize that, meaning simplify as much as you can. And so the basic principle is that for the complex fraction, let's say we have A over B over C over D. As this is a fraction on top over fraction on the bottom. And that's why it's called complex fraction. So you're going to turn the middle division sign right here. Let me make it in color. So right here, right, middle division sign, you're going to turn that into a multiplication sign. And when you do that, just like how we're dealing with the turning the division into multiplication, then you're going to flip the denominator, meaning we're using the reciprocal of the denominator. So use the reciprocal. Okay, so reciprocal of that will be D over C. Okay. Then you multiply across after that. So it's AD over BC, right? So this is a general principle. How we deal with the complex fraction. And for the rational expression, very similar. So here, the top is a rational expression. So 5 over x, keep as is. On the bottom, we're going to turn into a single fraction. So right here, you're going to make it 1 over 1. And then use LCD, like what we did yesterday. So LCD will be x. So for the first fraction, you're going to multiply both top and bottom by x. Keep the second fraction. And we're going to get 5 over x on the top, stay as is. On the bottom will be x over x plus 3 over x. Now we call these like fractions, then we can combine them to our like fractions. So we get 5 over x, keep the denominator x, and then add in the numerator x plus 3. Right, and from there, now we use this principle on the side, right? So we're just gonna flip it. So turn the division in the middle, 5 over x, it becomes multiplication, then flip the denominator. Okay, so x goes on top, x plus 3 goes on the bottom. So you cancel the x, and we get the final answer, which is 5 over x plus 3. Okay. Any question about this?
No.
Okay, very good. So I'm going to check the answer, right? 5 over x plus 3. Let's do it. And I want you guys to try one of this. Okay, so show me another. Okay, you're going to try this. All right. Let me just clean the screen. I'm going to share the screen one more time. Okay, here we go. So try that first. All right, so let's go over the solution. Very similar to the previous one. First of all, you just carry over the top fraction. And the bottom will turn into 1/1. Use LCD with x and multiply both top and bottom by x. For x, so we get 9/x over x over x, and then 4/x. And will be 9/x and x plus 4/x. Now it's a complex fraction by nature, so we're just gonna flip the denominator. So multiply, turn the division here into multiplication and use the reciprocal of the bottom. So x goes on top, x plus 4 on the bottom. Then from there, just cancel these x, right? And we get 9/x plus 4. Okay. Yep. Any question about this?
No.
Okay, very good. So should be 9/, check it, x plus 4. Okay, so you click on check answer. Okay, and it's good. All right. So let's look at question number 2. Next problem. So it says it's a slightly more complicated. So let's get to it. So first of all, let me print the screen. There we go. Okay. So go back here. So we're gonna combine the fraction on the top first, right? We're gonna take it out first. Just take the numerator first. Can we just combine them like this? Since 6 is we have since 6 on top. Does that work? Is this equal to 6/xy? What do you think?
No, we have to match the denominator.
Yes, very good, right? So this is not good. This is not right. Right, we cannot do that unless 6 is on the bottom. Then we could do that, but because 6 is on the top, so this is not right. Right? We still gotta find LCD and then go from there. So again, LCD here will be x1, x times y. So for the first one, we're gonna as 6 x times y, 6 times y here, and the second one y times x, and then 6.
I'm sorry.
Yep, sure.
We can't see.
Wait. Okay, sure. Okay. Yep. Yeah, very good. Thanks for the reminder. Yeah, sometimes I forget. Yeah. So basically, can you see now?
Yes.
Yeah.
Okay, very good. So LCD is this, right? XY. Just basically turn both into the LCD. And now they both LCD XY, so keep as this. And then you get 6y minus 6x. And if you want to factor this, we could actually factor this, but yeah, we could do that. We could factor 6 y minus x. It probably looks slightly simpler over x1. This is the simplified result, right? So the top would become this 6 times y minus x over xy. Now, similarly, we take the bottom, right? It's a sum of the two fractions. So we still got to simplify into the single fraction first before we can simplify the complex fraction. And similarly, LCD here is going to be x times y. Yeah, so we multiply the y on both top and bottom for the first fraction and the second fraction. Multiply x on both top and bottom. Now the allowed fraction is y over xy plus x over xy. y, then we end up with xy and then y. That means we simplify into single fraction. This is the same thing as that. So y plus x over xy. Now we're gonna flip the middle fraction here, right? And turn it into a multiplication, and then we simplify from there. So it will be 6 times y minus x over xy. Multiply by, flip that, it will become xy over y plus x. We're going to cancel the common factor. Same thing here, cancel. And the answer will look like this: 6 times y minus x over y plus x. Okay. Any question about this? Okay, no questions. Very good. So typically, right, no matter how complicated it is, you just decompose it. Work on the top first, work on the bottom later. And once we get a single, the key thing is to get a single fraction here, then we move forward from there. Okay, so now let me put in the answer first. So check it. Okay, save times y minus x over y plus x. Yeah, check it. It's good, right? Okay, so now you guys try another one. Yeah, very similar one. And let me share the screen. Here we go. Yep. So while you're working on this, I'm calling attendance. Okay, hi, are you here? I don't think so.
Are you calling me Kaung? Kaung?
Haein. So you were here yesterday too, right? Are you here yesterday?
Yeah, me, Kaung C2, right? Hello?
Haein, that's your first name, right?
Yeah, Kaung SITHU.
No, I'm not calling you. I'm calling.
Okay,
You
sorry.
show the roster, I guess. And you show the roster to everybody, so we don't get confused.
Excuse
I think
me,
it's
sir.
me.
Are you calling me?
Yes. Hi. Do you see?
Oh,
Yeah. Do you see this first name here? Hi.
no, 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 no. Yeah,
It's not you.
my full name is Hing Tak Ao. See,
So this is.
I join every day.
What do you mean? Your full name is like this?
Yes,
Uh, so Hi is your first name, right? Hi Ted.
yes, yes.
Hi Ted.
It's
That's
me.
you. Okay. All right.
Yes,
Were you here yesterday?
yes, sure.
So yes, I guess we got. So Abra, are you here?
Yes,
Okay, very good. And Amaya,
I'm here.
yeah, okay, very good. And Michael are you here?
Here.
Okay, very good. Um, Tamar, Tamir John, are you here?
I'm here.
Okay, very good. And Daniel, are you here?
yes, I'm here.
Very good. Um, Saphimonia, you're here, right?
Here.
And Peter,
Yeah, I'm here.
okay, very good. And Ivan,
Here.
okay, great. And Pam is here, okay,
Yes, I'm here.
yes. And Carl,
Yeah, I'm here.
okay, very good. And Victoria,
Here.
okay, great. And Lisha,
Yes, I'm here.
you here, okay, very good. And Guan Yu,
I'm here.
yeah, okay, very good. Okay, so I get everybody. So let's go back to that question here. So one more time, we get this rational expression. So it's very similar to the previous one. So basically, we just tackle one at a time, right? So numerator first and use the LCD will be x times y. And just multiply this by y. Multiply the second one by x. And we get the same denominator. So it's y minus x over xy. So get the single fraction, which is good. And then bottom very similar to x of 2 over y. And LCD is same thing, x times y. And x times y for the first one multiplied by y. The second one multiplied by x. Yep, so we end up with 2y, xy on the bottom, 2y plus 2x. And typically we would just factor out the GCF2, and it's a little bit easier that way. And over x1. Get a simple fraction again, so we can write it carry over. Bottom very similar. X over xy. And we're going to turn into multiplication, right? Turn the middle one. Always focus on the middle one. And y minus x over xy. The xy goes on top. and the other one goes on the bottom. And we cancel the common factor xy. That's gone. And we end up with the result y minus x over 2 times y plus x. Any question about this?
No.
Nope. Yeah, great. So let's check the answer. So it's going to be fraction first, y minus x. On top, and then 2 times y plus x. And let's check the answer. And it's good, right? It's perfect. Okay, so let's level up a little bit. So let's look at a little bit more complicated ones. Yeah, sometimes it requires factoring, right? And let's look at that as well. So show me another. Let me print the screen. This one is already a single fraction on both top and bottom, but it does require a little bit of factoring. So typically what we'll do is, let's carry over that first, x minus 2 over x squared 49. Now let's turn this division in the middle to the multiplication first. Now you're gonna flip the denominator here, right? So x plus 7 goes on top, and then x squared minus 4 goes on the bottom. Okay. From there, we're just gonna factor. So factor this, and then simplify as much as you can. So let's see. So x is 2. So it's a difference of 2 squares. So first one will become x plus 7, x minus 7. And second one, x plus 7 here, become x plus 2, x minus 2. Now, next just canceling the common factors. Okay, so cancel this common factor, right? Cancel this. And again, the top has nothing left. You still got to put back the invisible one. So it'll be 1 over x minus 7, x plus 2. Right. Don't forget to put back the invisible one, right? If you cancel everything on the top, what if, let's say nothing on the bottom, let's say it's x minus 7 on the top, x plus 2 on the top. On the bottom, just canceling everything, and it's over 1, then anything over 1 stays as is, right? So that's fine. But so if one is on the bottom, then you can omit it. Okay, now we get this. In this case, we need to put back that invisible one to make it a valid answer. Okay. No question, right? Okay. And that would be this 1 over x minus 7 and x plus 2 times x plus 2. That should check the answer. Okay, it's perfect. Okay. Now just try one yourself. Okay. Yeah, try it. All right, let's go over the solution really quickly. So one more time, carry over the fraction on the top. We get x minus 9. On the bottom, we want to factor, we can factor immediately, right? So x plus 2, x minus 2. And flip this bottom, right? Like here. So x plus 2 goes on the top. And we can also factor this x squared minus 81. The x plus 9 minus 9. Okay, now from there, just cancel the common factors. X 2 get cancelled. Minus 9 get cancelled. Again, that's the invisible one. Put it back. So we get 1 over x minus 2, x plus 9. No question. Okay. Any question?
No.
Okay, very good. Minus 2, x plus 9. So get a fraction side, 1 over x minus 2. Yeah, x plus 9. Yep, that should be good. All right, so now let's look at the next one. It just get a little bit more, every time just get a little bit more complicated. And let's look at the action another. So I give you a chance to work on your own version when you finish class on a homework assignment. Yep, here you go. So again, top and bottom is not a single fraction yet. So we gotta simplify, combine them first. So 1 over x 7, 1 over x minus 7. We're gonna use LCD. LCD turned out to be x plus 7, x minus 7. Let's combine them first using LCD, x plus 7, here x minus 7, 1 times x minus 7. And the second one, multiply by x plus 7. 7 times x plus 7. 1 times x plus 7. Now, same denominator, so we're going to turn into a single fraction here. So x plus 7, x minus 7. And on the top, we get x minus 7, adding x plus 7. Right? You can omit that one, right? It's not needed. This is, we can make it invisible or omit it. And when we combine them, we cancel the 7 as 2x. So it's kind of like simplified to lowest term. So we get this as a fraction on the top. On the bottom, very similar. It's 7 minus 1 over x minus 7. And again, we're using LCD. LCD is going to be some x plus 7. And we're just going to combine them one by one. X minus 7 first. Minus x minus 7. That happens on the top as well. Minus 1 over x minus 7. X plus 7 times x plus 7. Now, same denominator, so we turn into a single fraction, minus 7. X. On the top, you can omit this one. This is okay. But the second, just be careful about the second one. So we omit it with the x minus 7. Now, second one is minus 1 times x, right? So it's minus x. Minus 1 times 7 is minus 7. Now we're going to cancel opposite terms, x and then minus x. On the bottom, it's just going to be minus 14 over x minus 7, x plus 7. Okay, so this is the bottom. Now they return into opposite fraction 2x over 7 minus 7. And then on the bottom, first similar settings, minus 14 over x minus 7, x 7. But on the division in the middle into multiplication, so 2x over 7, x minus 7. I turn this into a multiplication and flip the bottom, x minus 7, 7 over minus 14. Now we can start canceling. So x minus 7 get canceled, x plus 7 get canceled. Now also we can reduce it, right? Because 2 going to minus 14 will be 7. So this becomes negative 7. So the answer, final answer will be minus x over 7. Any questions about this?
No.
Okay, very good. So minus x over 7. And check the answers. I'm gonna ask you a quick question, guys. Do you feel like this is too easy? I can give you some more challenging questions. If this is a little bit too easy for you guys, let me know, right? What do you think? Is this it's like no challenge for you guys? I can I have a whole bunch of other questions which is a lot more complicated than this. If you guys want to give a shot, let me know, right? But for now, let's just do, yeah, let's just try some of this question. This very similar one. So let's move on to the next one now. Okay. Next problem. Yep. So let's try this one. Let's just try it first. So from another. This one is getting a little bit more complicated because we have a lot more terms. So try this for a second. Very similar thing, right? Just have to simplify as much as possible, and we go from there. All right, try this. All right, so let's go over the solution for this one. This one a little bit more complicated. So again, I copy the top. This is 2 and adding 1 minus 2 and then 1 plus 2. But again, we use LCD. It's going to be y minus 2 times y plus 2. Then for the first one, you multiply both top and bottom by y plus 2. Y minus 2 plus y plus 2. And this is y plus 2. Y plus 2. And on the second fraction, multiply both top and bottom by y minus 2. Minus 2. Y minus 2. So we end up with this y minus 2 and y plus 3. You can FOIL this, right? I'm going to show you something which is a lot quicker to expand this trinomial here. And this perfect square, our trinomial. Y minus 2 squared 2 and y minus 2. So the method here is we're going to keep the same denominator, right? Y minus 2 and y plus 2. And here is a y squared. So the first term is y squared. Second, this, yeah, so that's first term. And second term, the sign will be the same as the middle sign. So with plus, we're going to do 2 times y. And the third term will be 2 squared. And this is how you expand a perfect square without doing the FOILing, right? Without FOILing this. I just want to show you. Okay, so the second one, y squared first term. Okay. And the sign will be the same as the middle sign here, minus 2 times y. Okay. And the last one will be 2 squared, same as that. And that's basically how you will expand the perfect square and using this shortcut, right? So y squared plus 4y adding 4. But if you prefer to FOIL this, no problem, do that. Okay. Just a little bit quicker. So y squared minus 4y adding 4. And the denominator stays the same. From there, we're just going to cancel the common, opposite terms right here. We can get canceled. So eventually, we end up with 2y squared plus 8. And we can factor out the 2. So it becomes 2y squared plus 8. Top on the bottom will be y plus 2, y minus 2. Now if we factor out the 2, and we get a y squared plus 4. Y plus 2, y minus 2, y plus 2. All right, so that'll be the top, right? We simplify the top. Now let's work on the bottom. Very similar. So copy that same denominator. I mean, just the sign in the middle is the opposite. That's all. So y plus 2 over y minus 2 minus y minus 2. Exact same thing, right? So I was thinking first y minus 2 and y plus 2. And from there, we're just gonna simplify them. So combine first y minus 2, y plus 2. But again, it's y plus 2 times y plus 2. It's a perfect square. And then the second one, y plus 2 and y minus 2. Y minus 2. So same denominator, we will keep as is, y minus 2. Y. Now we get y plus 2 squared minus y minus 2 squared. Because it's minus sign in the middle, so it's when you expand it, you should be a little bit careful about that. Now, one more time, like what we did here, right? So it's that same thing. So y squared first, adding 2 times 2 times y, that's 4. 2 squared, that's 4. Yes. Here, y squared. Second one, 2 minus 2 times 2 times y. So that's 4y. 2 squared, that's 4. Okay. Then, distributed, right? You can expect invisible one distributed, and then we cancel a couple terms. That's 4y, that is 4 minus y squared, adding 4y minus 4. And minus 2, y plus 2. We cancel the y squared, and we cancel the 4. And we end up with a y. Over 1 minus 2, y plus 2. So this is the bottom, right? The fraction from the bottom, fraction from the top. And we're just gonna simplify from there. Now, here, let's just get to the bottom of it. So it could get very lengthy because nature of this. So yeah, the top we just did it, right? So 2 times. Move this a little bit. So 2 times y squared plus 4 and y minus 2 times y plus 2. Now we're going to turn the division, right? Here into multiplication. And here we're going to flip the bottom, which is this. So y minus 2 goes on the top, y plus 2 goes on the bottom, goes on the top, and then bottom will be y. And from there, we just cancel the common factors, so cancel this, cancel this. Then 2 going to 8 is 4 times, so it's 4y. So eventually, we end up with y squared plus 4 over 4y. And that's the final answer here. Do you have any question about this?
No.
No, very good. Y squared plus 4 over 4y. Let's check it, right? Y squared plus 4 over 4y. Yeah. Yep, that's perfect. It's good. Okay. And let's move on to next question. So it gets a little bit complicated. So that's how it is. I think that's all right. That's everything. Yes. So this is the most complicated questions in this section right here. And next thing we're going to talk about the rational equations. So basically, rational equations. We're going to learn how to solve for the x. That's basically what it is. Just like the simple linear equation, we're solving for x, right? Rational equations, we also have single variables here, and then we can solve for x. So let's get to it. Let's look at problem 1. Okay, so this is a simple one. So show me another. Let's start with the simple version of the questions. Let's learn how to solve this. So typically, when we have a rational equations, most important thing is find the LCD. So step 1, solving the solving rational equation. Step 1, find LCD. The second step, multiply every single term by LCD. Multiply each term by LCD. And third one is simplify and solve for x. I show you how to go about this. Simplify and solve for the variable. It could be x, could be y, could be any variable, and then solve for the variable, whatever variable that is. So let's apply this right general principle. So LCD here. Any suggestion will be the LCD here. Is it x squared? You always use the higher power, right? So if you have see the same same type of variable but with different powers, you always use the higher power. Actually, in terms of LCD, use the higher power of all the variables. Okay, so x squared it is. The next step is multiply each term by the LCD. So you will just multiply 1 by, right? So you're just going to do 1 times x squared and minus 3 over x times x squared and over 10 over x squared times x squared. As you can see, 1 times x squared is x squared. X going to x squared is x. We get 3x here, and then x squared are cancelled, right? So we get 10. All right, so then also some people prefer to do it like this, right? You can also make everything a fraction. And over x squared, right? Make it a fraction, and you're gonna multiply x squared here, x squared here, x squared here. If that's easier for you, right? You can go with that. So so first term will become x squared, and x going to x squared that become x, so that's why it's 3x. And x squared to cancel, got 10, right? So it'll be the same right here. And from there, we just move everything to the left-hand side, so subtract 10, and 10 here. Cancel the 10, we get x squared minus 3x, and it's equal to 0. And this is a trinomial, so we can factor, okay, just like what I showed you guys at yesterday, break down x squared, break down 10. It's going to be 5 and 2. Minus 5 plus 2. And we get 2 factors, x minus 5, x plus 2. And so each one of these has a solution, right? So we basically have 2 solutions, x minus 5 equals 0. So we use 0 factor property and then solve for x. So adding 5 here, we get x equal to 5, minus 2 here, we get x equal to 2. So x equal to 5, x equal to 2. So we have 2 solutions. And usually, we should check it. Sometimes, one of the solution may not work. So let's plug into the original equation here. So the solution of 5, let's see, will be 1 minus 3 over 5 for 10 over 5 squared. We don't know yet. So 1 minus 3 should be 250. That's 10 over 25. And then if you simplify, reduce both top and bottom by 5, you get 2 over 5. That means this is good, right? This solution is good. Now, if you plug in the -2, okay, so 1 minus 3 over -2 equal 10 over -2 squared. It will be minimal there. So 1 plus 3 over 2, 2 negative 10 and positive, that's 2.5. This is 10 over 4, that's 2.5. So it's good. 2.5, 2.5. So both solutions is valid solution. So basically we have a couple solutions. Yeah. Any question about this?
No.
Okay, very good. And let's put in the answers 5 and -2. Okay, let's see, move to H5. Make sure it's the correct answer. Yeah, it's perfect, right? It's a correct answer. So you try one of them. Let's see. You try this one. All right, let's go over the solution here. So LCD will be the same, right? X squared. So basically you multiply every single term by LCD. I guess I will do the other one. So number one minus 6 over x. And go 27 over x squared. You multiply every single term by x squared. And we simplify. So x squared minus x going to x squared 6x. And that's x squared. Cancel 27. I subtract 27 from both sides of the equation. And like how we solve the linear equations, we're solving the quadratic equations here. And so that's 0 on the right, x squared and 6x 27. And similarly, factor by the trinomial. And it will be 9 and 3. And now we minus 3 with positive. Multiply that, you get minus 27, and then you get minus 6. So the two factor will be x minus 9. And then we can solve for each one of these. X minus 9 equal x3 equals 0. Then x equal to 9, adding 9 from both side equation, minus 3 from both side equation. So it's -3, yeah. Okay. Any question about this?
No.
No, very good. -3 and 9. Okay, let's do it. All right, let's move on to a little more complicated one. This one, okay. And this one, you just gotta, sometimes the equation will be simpler. You see, this one actually, the equation will be simpler. So let's look at it. So we start with the LCD. And here the LCD, not easy to see, but if you factor this right here, x squared minus 1, and this will become x plus 1, x minus 1. Now, all of them have x plus 1, x minus 1. So the LCD will be x minus 1, x. So we're going to multiply every single term by this. So we put this on in the numerator, right? That's a lot easier that way. So 1 times x minus 1, x plus 1, top, x minus 1 on the bottom. Second term, 1 times x minus 1, x plus 1 over x plus 1. And on the right will be minus 14 over, okay, x plus 1 on the bottom, x minus 1. And multiply by x plus 1, x minus 1. I start canceling stuff, right? Canceling the common factors. And right here, this one get canceled. Minus 1 get canceled. X plus 1 get canceled. Plus 1, minus 1 both get canceled. Then we, so by multiplying both every single numerator by the LCD, we are guaranteed to get rid of the denominator, right? No more denominator. So we can jump to the solution. X plus 1. We don't need that invisible 1. Get rid of it. Right? No need for that. Get rid of it. Get rid of it. Adding x minus 1. The right will be minus 14. And as you can see, the equation here is a lot simpler because it's simple linear equation. So get rid of the 1 minus plus 1, 2x equals 14 minus 14. Then we divide both sides of the equation by 2. X equals -7. And usually we will check it. We will check the solution. You know, sometimes the solution may not work. So let's check the solution, right? So here, replacing in the original equation here, we're gonna replace all x with the -7. See what happens. So this is 1 over -7 minus 1 plus 1 over -7 as 1. And then this is minus 14 over -7 squared minus 1. And the first one is 1 over -8. So it's -6 is minus 1 over 6. And on the right hand side is minus 14 over 7, 49 minus 1, 48. And again, so this is minus 1 over 8, minus 1 over 6. We don't know yet, so question mark. And again, we use LCD. We will check that LCD here is 48. Not exactly 48, but we're just gonna make sure it's right. So multiply 8 here, 8 here. And we're gonna end up with minus 14 over 48 equals to minus 14 over 48. And this means solution is valid. And that's why sometimes some questions have no solutions. So checking the answer, it's necessary. Right? It's necessary to confirm the answer, but sometimes it's you run out of time, right? So in the exam settings, if you run out of time, then you may skip it. But most of the time, we will double check the solution, making sure it's good. Okay, so this is the answer, minus 7. Let's check the answer. Yeah, it's perfect. So now you guys try a question, similar question. I'll give you some minutes, couple minutes to try that. Okay. All right, let's go over the solution. Again, LCD will be, this one will become 2 minus 2. So LCD is x plus 2, x minus 2. So you multiply every single top right here, here, right? Multiply every single numerator by the LCD. So start with the first one. So we get 1 times 2, 2 over x minus 2. And so the rationale behind this, why we can do that is this, right? Let's say you had a plus b equals c. Right? If you multiply every single term, right, you can multiply on the left, you can multiply by d, right? Right, you can multiply by d. And then we still get a different equation, but it's still equation. So it's a times b plus b times d that is equal to c times d. And that's why you can multiply d. Right? Because as soon as you multiply to every single term, and that works. That's why this we apply that property in this particular setting, the rational expressions. And then similarly to the second term, and you do 1 times x plus 2, bottom is x plus 2. And then the third one minus 6 over x plus 2 minus 2. Same thing here, x plus 2, x minus 2. Now we're going to cancel all the common factors. Minus 2 can cancel, plus 2 can cancel, this one cancel both. Then again, we end up with a very simple equation, x plus 2 plus x minus 2. Omit those ones. It's not needed. We get rid of the 1, get rid of the 1. So equal -6. Again, cancel the 2 and minus 2. So 2x equal to -6. And divide 2 from both sides of the equation, we get x equal to -3. So yeah, it's pretty similar to the one we just did. So no questions, right? I'm checking, right? Did you? I should probably check it. I will skip the checking step. You should check it though. Plugging the -3, making sure left hand side equal right hand side. To be exact. Okay. This one is similar. So I'll let you try this one yourself. Okay. And let's go over the solution. And again, this one is x plus 2. Factor that, it becomes x minus 2. So we know that LCD is going to be plus 2 times 2. So you're going to multiply every single term on top by the LCD. So it'll be 2 times 2 times x plus 2. Bottom is x plus 2. Right here, x times x plus 2, x minus 2. Bottom is x plus 2, x minus 2. On the right hand side, 13 over x minus 2, then we do x plus 2, x minus 2. So we cancel the common factors, cancel the common factors here, here, and also this. So end up with the 2 times x minus 2 plus x equal to 13 times x plus 2. So this is a linear equation with with one variable, so 2x times 4 adding x equal 13x adding 26. Combine 2x and x, you get 3x minus 4 equal to 13x adding 26. Right, and typically you move this 3x to the right hand side, to the left hand side. So you subtract 3x. So again, minus 4 equal to 10x adding 26. Now you subtract 26 from both sides of the equation. Cancel that so the 10x reverse the order to minus 30 and divide both sides of the equation by 10. So the final solution is x equal to minus 3. And typically we can check it, right? This time I'm going to check it, check the solution here. So, apply -3 into the equation, so 2 over minus 3 added 2 plus minus 3 on top over minus 3 squared minus 3. We don't know yet. Put a question mark on top, 13 over minus 3 minus 3. For the first term, it was 2 over -1. Second term, we simplify as minus 3 over 9 minus 4. It's 5. And then on the right is minus 13 over 5. And it's minus 2 over 1, minus 3, 5. You multiply 5 here, and you see it's minus 10 over 5, minus 3 over 5. It's the exact same thing as minus 13. When you combine them, they are the same. So that means solution is okay. I believe it's a valid solution, right? Because you check the plug into the original equation and check it. Any question about this? Yep, it's good. Right. Let's try question number 4. All right, and this one, you need some factoring down here, right? Now, go from there. So try this yourself. Then we're going to go over solution in a second. Let's go over the solution. So again, this when we factor this one here, will be x plus 4, x plus 6. And that's give us the LCD. And that's exactly the LCD. So x plus 4, x plus 6. We're going to multiply every single term by the LCD. So for the first term, multiply here, here, here. So 2 times x plus 4, 6 over x plus 4. Second one, 3 times x 4 over x plus 6. And on the right hand side, that's equal to minus 3x. Yeah, times x plus 4, x plus 6. Other is the same, x plus 4, x plus 6. Now we cancel the common terms. Here, this is gone, both gone on the right hand side. And we get a simple linear equation, 2 times x plus 6 plus 3 times x plus 4 minus 3x. Then distributing combine like terms, solve for x. It's 2x is 12, adding 3x, adding 12, or to 1 to 3x. Yeah, I will continue. So we combine like terms 2x, 3x, 5x. 12 plus 12 is 24. That's equal minus 3x. Now adding 3x from both sides of the equation. Cancel that, okay, 0. Ax plus 24 equals 0. Then subtract 24 from both sides of the equation. Cancel that ax equal to negative 24. Then we divide both sides of the equation by 8. Okay, x equal to 3. Yeah. And we can double check, right? Let's quickly check it. So let's plug this back into the original equation here. Let's see what happens, right? So let's check solution, check solution. So 2 over negative 3, adding 4, plus 3 over negative 3, adding 6. That's left hand side, but we don't know yet. Question mark minus 3 times negative 3. They turn into positive there. And negative 3 squared plus 10 times negative 3, adding 24. Now, on the first fraction, difference over 1, which 2, second fraction is 3 over 3, that's 1. And then negative 3 times negative 3 is 9 over 9, adding 9 minus 30, adding 24. And that's 33 minus 30, so 2 plus 1, that's 3. 9 over 3 on the right, that's 3. 3 equals 3. Yeah. So if you find a solution, you always end up with the proper result, right? With the value equation. So that's the solution here, and 3. Let's check it. The internet is a little bit slow. Okay. See. So yeah, so that's let's look at the question 5. Yeah, I guess you guys can try this. Another. Yeah, they're slightly different, and this one is really interesting. So let's see. Okay, try this. All right, guys, we're gonna take a break for half an hour. So come back at the 10:45. Okay. I'm gonna record it. Very good. I pause the recording. Very good. Reminder. Yeah. Thanks. Okay. Very good. Yep. Do you finish yet? Give you a couple more minutes. All right, so let's go over the solution here. So first of all, the LCD is going to be product of all three denominators. So this one, we're going to go back to the traditional method. So 1 minus 3 plus 8. So very similar, you can multiply every single numerator by the LCD. So it's going to be slump problem. So I'm going to put on top 2 minus 8, 1 minus 8, 1 plus 8 over 1 plus 8. Eventually, all the denominator will be gone. So it's only dealing with the numerator. So 3 times 8, 8, 6 over 1 minus 8. And yeah, this is equal sign. Yeah, and then adding 5 times 8, 8, 8 over 8. Now again, we're going to start canceling the common factor. So this one is gone. This one is gone. A is gone. End up with a 2a times 1 minus a equal to 3a times 1 plus a. So we're dealing with a quadratic equation. That means possibly we're going to have two solutions here. And 5 times 1 minus a, 1 plus a. And there's a difference of 2 squares, so it will become 1 minus a squared. And this really combine like terms, it's really, so you get 2a minus 2a squared on the left, on the right is 3a and 3a squared, and adding 5 minus 5a squared. Okay. Then combine like terms, this one we can also probably combine those, we end up with 3a minus 2a squared equal 3a. Let's write the leading term first. So combine this minus 5a squared plus 3a squared, that's minus 2a squared plus 3a adding 5. Yeah, I guess no, we only have one solution. Okay, adding 2a squared, adding 2a squared first. We cancel the leading term a squared. Then subtract 2a from both sides equation. Subtract 2a here, subtract 2a. So that we get a plus 5 equal to 0. So a is going to be -5. Okay. Now we can quickly double check this, make sure the solution is good. I'll check it. So go back to the original equation. And replace all a with the given number 1 plus 5. Put to 3 over 1 minus 5. Then adding 5 over -5. Yeah, so we don't know yet. So we're going to do 2 over 6, that's 1/3. Then we get 3 over -4 minus 1. Yeah. No, this is -5. I guess I overlooked something. Yeah, this is minus -5. Yeah, I overlooked. Right here, this is 1 minus -8. A is -5, so it's 1 minus -5. And this becomes +5. So it's 1 plus 5, 6. And the first one is 1 minus 1 plus 8 actually is 1. We should also off, so then just redo it. -5, so it's 2 over 1 plus -5, 1 minus 1. So it's 2 over -. So this is -half. And half minus 1. So this -half as well. So left hand side or right hand side confirmed. Answer is good. So the answer is -5. All right, so that's pretty much everything on section about the rational equations. Then we're going to move on to the next topic, which is application. So we're going to apply the rational equation to a different scenarios, right? We're going to take a look at some questions on different. One of the famous ones is the number problem. We're going to look at the number problem first. So let's get to the application of the rational expression and rational equations. Question number 1. Okay, so the question look like this. So we have the sum of the number and its reciprocal is 50 over 7. And so we find a number, right? So this is a typical word problem. So we have 2 variables here. We need to assume the number as x. That means reciprocal of this number will be 1 over x. Reciprocal and the sum, right? Meaning adding those 2 numbers. So x plus 1 over x, it's going to be 50 over 7. And from here, we're going to solve for x. So first of all, we find LCD. The LCD here, we can make this a fraction, right? The LCD will be 7x. Just like the other questions, we're going to multiply every single term by 7x. So first one, x times 7x over 1 plus 1 times 7x over x. And we get 50 times 7x over 7. And again, we cancel the common terms. X is gone, and 7 is gone. So we get 7x squared, adding 7 equal to 50x. Okay. You're going to subtract 50x on both sides of the equation. So we're going to get a quadratic equation. So on the right is 0, left is 7x squared minus 50x adding 7. Now we're going to factor this, right? So break down 7x squared, 7x and x. And we're gonna break down this positive 7. So it has to be both minus, right? -1 minus 7. Then let's check it, cross multiply, we get 7x times -7 is minus 49x. -1 times x is minus 1x. 5x is minus 50x. So that means we have to convert all three numbers, all three terms. So the two factors will be this, 7x 1 times x minus 7 is 0. And we're gonna solve for each equation here, linear equation, 7x with 1, set that equals 0, x minus 7, set that equals 0, and 7x equal to 1, x equal to 1 over 7. And second one, adding 7, you get x equals 7. All right. It should be good, right? So we can double check it by plugging that into the equation here. So let's check the first one. 1 over 7. Maybe 1 over 7, adding 1 over 1 over 7. 1 over 1 over 7 is 1 times 7 over 1. So it'll be 49 basically. No, 7. So 7 equals 49 over 7. So it's confirmed. So it's 1 over 7 equal to adding 7 over 1. 1 over 1 over 7 is like divide by 1 over 7 means multiply by 7 is 7. This is 7 and 1 over 7, that's 50 over 7. So it's confirmed. And since we confirm this, we also convert 7 because you see 7 goes here, and 1 over 7 goes here, then 7 goes here, then combine them, you still get 50 over 7. So x equals 7 is also confirmed. We also end up with 50 over 7 equals 50 over 7. So both answers are good. So we have two solutions here. 1 over 7 and the 7. If we check it, they both good. Okay. So I guess you try one of this. No? No problem. Let's move on to the next question. You can try the next question. Yep, you try this one. Sum of the reciprocal through consecutive natural numbers, find both numbers. Give it a shot. Okay, so let's take a look at the solution to this question. So in this particular question, we have two different numbers, but they are two consecutive natural numbers. So you can assume in a smaller number as x, and then the bigger one, right? This bigger number, it's gonna be. But it tells us the sum of the reciprocals. Reciprocal of x is 1 over x. Reciprocal of the x plus 1 is 1 over x plus 2. And they tell us the sum of those two numbers is equal to 5 over 6. So that means 1 over x plus 1 over x plus 1. That is equal to 5 over 6. Now, in order to solve this rational equation, we need an LCD. And the LCD will be 6 times x, and then times x plus 1. I just multiply every single numerator by the LCD. So 1 times 6x, x plus 1 over x, 1 times 6x, x plus 1 over x plus 1. And the last one will be 5 times 6x plus 1 over 6. Now we're starting canceling terms. This is common factor cancelled. No. One x get cancelled on the first fraction, x plus 1 get cancelled on the second fraction, 6 get cancelled on the third fraction. So end up with a 6 x plus 1 plus 6x. On the right hand side with 5 times x plus 5x times x. Now we can distribute it and then simplify. So 6x adding 6 on the left, adding 6x equal to 5x squared, adding 5x. And combine those two, you get the 12x adding 6 equal to 5x squared, adding 5x. And subtract 12x, subtract 6 from both sides of the equation. So we cancel that, we get 0 on the left, 5x squared, minus 7x, minus 6. I'm going to factor this, so it will be 5x. We need to get minus 2 here, positive 2 here. When you cross multiply, you get minus 10x, adding 3x, just minus 7x. That confirms to the middle term, so that we get two factors, 5x plus 3 equal to 0, and x minus 2 equals 0. So we have ended up with the two solutions. 5x equal to 3. So x equal to and 3 over 5, adding 2. X equal to 2. So we get two solutions, is that right? Both the solution works. What do you think? Remember, the given condition is a natural number. This is definitely not a natural number, right? This is the negative fraction, is not natural. Yeah. So definitely this one is out. Minus 3 over 5. I'm still gonna double check 2, making sure 2 is good. So you're gonna plug 2 back into the original equation. 2 is a natural number, but we're not sure yet. So in this case, checking the solution is very, very crucial, because not all the solution works here. Sometimes there's no solution. That's possible. So you get 1 over 2 plus 1 over 2 plus 1, which is 3, That's one of the should be 5/6. So it's half adding 1/3, and it is 5/6 because multiply 3 here, 3 here, 2 here, 2 here. Get 3/6 adding 2/6. That's exactly 5/6. So that means this is the correct solution. Only one, right? This is the only solution here. So checking the final answer, it's necessary most of the time. Okay, so let's go back, put in the answer. So 2 is the correct answer. Check it. 50% should be more numbers. This all possible, but no, it's natural number. So they want 2 answers. But it's not a reduce. So this is not right. But we do have only one solution here. By numbers. Oh yeah, so they need both numbers, right? So x is 2, then next number will be 3. That's what they need. We do find a number, but we need to put both numbers. Yeah, because 2 consecutive natural numbers, and then the next number will be 2 and 3. Yes, that's good. Let's look at question 3. The number and then twice of this reciprocal. Okay, so it's slightly different. You try this, right? You give a shot, see what happens. Sum of the number and then twice the reciprocal equal to 51/7. And then solve for the final number. All right, so let's go over the solution here. So the sum of the number, we assume this number will be x. Reciprocal will be 1 over x. Twice the reciprocal will be 2 times 1 over x. So it's going to be 2 over x. So x plus 2 over x, that's equal to 51 over 7. So the LCD here is 7x. So replace multiply every term by 7x. 7x, 2 times 7x over x equal to 51 times 7x over 7. Then let's simplify. So we get 7x squared, cancel the x, adding 14 equal to cancel 7, 51x. Then subtract 51x on both sides of the equation. And so that's equal to 0. So 7x squared minus 51x adding 14 equals 0. So let's factor this polynomial here. 7x and x. 7 and 2, both negative. When you cross multiplying, that will be minus 2x, minus 49x, minus 51x. Middle term, first term, last term. So 2 factors is going to be 7x minus 2 equals 0. Yeah. That's first factor. Second factor is x minus 7. And then we solve for x for each variable here. Then 7x equal to 2 and x equal to 2 over 7 for the first fraction. Second one, x equals 7. And here it's important to check it, right? It must be reduced fraction or integers. So let's check the first answer, x equal check. X equal to 2 over 7. So going back to the original equation, so x equal 2 over 7 plus 2 over 7. And that's, we don't know yet. 2 over 7. Let's see if that works. 2 over 7 plus this, you could treat it as 2 over 1. Right? So 2 over 1 times 7 over 2. And then cancel the 2. We get 2 over 7 plus 7 plus 7, and then 7 and 2 over 7. That's 2 over 7. That's equal to each other. This is 2 over 7 equal to 2 over 7. So the first solution is good. Now let's check the second solution when x equals 7. I think it's also good. So x equal to 7. 7 plus 2 over 7. That's the same thing, right? 7 to 7. That's equal to 7. Check. This is also good. Both solutions, it's valid solution. So going back here, so okay, so 2 answers. Let's check. Is it? Yeah. Okay, so yeah, so let's look at the problem number 4, right? In your in section 4, application of the rational expressions. Again, problem number 4. It's about the speed and then the distance b and then the time t, right? The relationship between those. Okay, so let me show you another. Okay. Share the screen. There you go. Okay, so the boat has a speed of 8 miles per hour in still water, right? Meaning when the water doesn't move, and the boat runs at 8 miles per hour. So the boat takes the same time to go 9 miles upstream as it takes to go 39 miles downstream with the speed of the current. So first of all, we don't know the speed of the current. So assuming speed of current is x miles per hour. Yeah, so same time, right? So The important thing is set up the equation based on the time t. The time t equal to distance over the speed, v over s, right? Time equal to distance over the speed. Distance over speed. Now we just need to figure out what happened when the, so I have two scenarios. Upstream, so the speed here, speed in the still water, the speed is 8 miles per hour, right? The boat speed is 8 miles per hour. And upstream, if the current, the speed of the water, right? The water current is x miles, what will be the speed when the boat go upstream and also the downstream? Any suggestion? Upstream meaning that the speed of current will reduce the speed of the boat, right? So that will be A minus M. And then downstream, meaning going downward, and the speed of current will help the boat move forward. So that will be A plus M. This is important because we're gonna set up the equation based on this upward speed, and then upstream speed and downstream speed. And we know it takes the same time. So the distance to go, it only go 9 miles upstream. So that means 9 over A minus X. This is amount of time it goes upstream. And then downstream is 39 miles. And that will be A plus X. And they will have the same time, right? So it's a distance over speed. 9 miles is distance, 39 miles is distance over the speed. And then basically we can cross multiply this and solve for X. So do this cross multiplication. 39 times A minus X. I probably should do the other way. Do the other way. So 9 times A plus X, it's equal to 39 times A minus X. From there, we're going to solve X. So distribute it, so end up with 72 adding 9X on the left. On the right, 39 times 8, 72, 7, 24, 312, minus 39. Yep, and then from there, we're just going to solve for X. So we're going to add in 39X first. So we get that. So it's going to be 48X adding 72 equal to 312. Subtract 72. Okay. Cancel that. So 48X equal to that's 240. Now we divide both sides of the equation by 48. And end up with X equal to 5. That means in the speed of the current is 5 miles. If you want to go upstream, that will be 3 miles per hour. Going downstream, that will be 11 miles per hour. So that's basically how this distance and the speed problem works out. Okay. Any question? You can check it by throwing the answer into the original equation here. So it'll be 9 over A minus 5. That's 3 hours. And the other one, 39 over A plus 5, that's 13. So it's 9 over 3 equal to 39 over 13. They both equal 3 hours. So for both upstream, downstream take 3 hours. And that means the final solution is correct. So the answer is 1. Okay, so now let's try let's try one of this. Okay, try this. Okay, so we have a I think Professor Dawes is joining our section, so let me just share them. All right, let's just go over the solution really quickly on this question here. So first of all, we set up assuming the speed of current x miles per hour. So similarly, we just need to figure out the speed in three different situations, which first one is still water. The still water speed is 11 miles per hour. So for the upstream, it will be 11 minus x because it's harder, right? Water is against the boat. That's why it's subtract x from the 11 miles. And then downstream, the water will help the boat. So 11 plus x. So it travels the same time, right? It takes the same time if going 24 miles upstream to going 42 miles downstream. So 24 miles upstream, the speed is 11 minus x. That's the time it takes to go upstream 24 miles. So going downward 42 miles, it's 11 plus x. So we set up the equation based on time. And time is equal to distance over speed. So this is speed. And we set up the equation based on this given condition at the same time. So we'll just cross multiply and then solve for x. So 24 minus 11 plus x equal to 42 minus 11 minus x. So it's 24 times 11, 24, 20, 264 plus 24x. Yep, so yeah, that's right. And then on the right hand side, 42, 42, 462. So minus 42x. Then we're just gonna isolate the combinable variable terms having 42x, having 42x, both side equation. Cancel that, we get 66x, adding 264 equal to 462. Now subtract both side equation by 264. We get 66x equal to 198. Then we divide both sides of the equation by 66. X equal to 3 miles per hour. That's the speed of current. And so that means in upstream will be 11 minus 3 miles per hour. Downstream would be 11 plus 3, 14 miles per hour. So the answer is X equal to 3. So if you want to double check, so we're going to double check by plotting the X equal 3 into the original equation here. So into this. So let's see. So 24 over 11 minus 3, that's 8. 24 over 8, 3 hours. 42 over 11 plus 3, that's 14. 24 over 8, exact same thing as 42 over 14. Both equal to 3. So the answer is 3 miles per hour. That's the speed of current. So any question about this? All right, that's good. And let's look at the next question. So next problem, it's very similar to the first one. It's about the speed, right? So that should try this one yourself. Give a shot. So two trains, train B travel 20 miles faster than the train A. Train A travels 222 miles in the same time as train B travel 300 miles. We're going to find out the speed of both trains. All right, let's go over the solution here. So train B travels 20 miles faster than train A. So we assume that slower train A the speed. Right? That means for train B, speed is first 20. Now train A travels 240 miles in the same time as it takes train B to travel 300 miles. This is for A, that's for B. So we will do 220 over X. It's the same time, right? The distance over speed equal to train B travel 300 miles for this speed. So 20. From here, we're going to just solve for X. So cross multiplying the 300X equal to 220 times X plus 20. So distributing the 300X equal to 220X, adding 4,400. Then subtract 220X from both sides of the equation. I get 80X equal to 4440. I divide 80 from both sides of the equation. It's going to be 50, is that 55.5? X equal to 444 by 80. Yeah, 55.5. That's right. So so X equal to 55.5. The other one is 75.5. And we can check it. 220 by 8. So if you so just plug in the X here, so it'll be 220. And we check. Get 220 over 55.5. No, actually, I overlooked. That's a mistake here. It's just going to be 55. I made a calculation mistake. I copied this. It should be 4,400, not 4,440. So here it should be 4,400 over 80. So cancel the X, cancel the 80, X equal to 55. 55 to be exact. Now 55.5. And if we double check that, then it'll be 55 here. And on the right hand side, 300 over 75. They both equal to 4. So this is the correct answer. So the answer is 55 and 75. So any question about this? All right. Last question here on this section, problem 6. So Stan took a 2-day road trip. She traveled 600 miles on the first day. However, he drove 3 hours longer on the second day to travel 825 miles. If Stan maintained the same average speed on both days, what was the average speed? Okay, and so that's try this one. Okay, let's go over the solution here. So assuming the only thing we don't know is average speed, so we assume it's average. So basically on the first day, on day one, you travel 600 miles. Okay, so I have Professor Dawes, he's joining us to talk about the final exam. Hello, Professor Dawes.
How you doing, Professor Lee?
Yeah,
Thank you for letting me in.
Yeah, so I'm glad you can come by. Yeah.
Of course,
So-
no problem. You could finish the problem and then I can speak afterwards, Professor Lee.
Okay, sure. So let me finish the problem really quickly. So so here we go. This is the question. So on day one, right? So 600 miles. So we're in total distance 600 miles over the speed, right? This is day one. Time it takes for Stan to finish the day one. For day two, this day two. So we have 825 miles of X as a time t. And then the day two, he drove 3 hours longer than the day one. That means if you're doing day two takes longer. So you do 825 over X. And then 600 over X, that should be equal to 3 hours. So we set up the equation based on the comparison of the time. So I guess they slow down. So it drove 3 hours longer on day two. So 820. And basically we can solve for this rational equation. So right here we have the same denominator. So combine them, the same denominator. So subtract the numerator, 825 minus 600 give us 325. On the right hand side, we turn it into a fraction. And we're using proportion one more time. Cross multiply and let's solve for x. So we get 3 times x equal to 225 times 1. So 3x equal to 225. So divide both sides of the equation by 3, we end up with 75 hours, 75 miles per hour, x equal to 75 MP miles per hour. So that is average speed. Do you guys have any question about this? So let's check the answer. Okay, it's Christian the answer again. Request we will if necessary. Time to answer. Sometimes it's, yeah, it's good, right? 75 miles per hour. That's good. So basically we wrap up the section 4.7 application of the rational expression. So I hand over to Professor Dawes. He's going to talk about the exams.
Good afternoon, class. My name is Dr. Dawes. I'm here to help with the testing. So your exam is on July 25th. I'm going to show you where you're going to take your exam. I'm going to show you the resources that we've created for you to help you prepare for your exam. And I'm going to answer all of your questions. Now, Professor Lee, were you
Yes,
able
I'm
to
here.
share that email with the students?
Oh, definitely. I'm gonna go to email right now. So,
Okay.
let's see. Okay, let me go to the email.
So class, the first thing I want you all to do is I want you to register for WebAssign if you haven't already. Professor Lee, I don't know if you can turn the chat on. I can give them a quick link.
Yeah,
But if
sure.
they don't,
Sure. I mean,
but while we're waiting, I'll do this. So this is what I need you all to do. I want everybody to go to webassign.net. Can everyone see my screen?
oh, so yeah, let me stop share. So I gotta stop share. So in that case, you can share.
Okay,
It's only allow one person. Yeah. Okay.
no problem.
Mhm.
Can everyone see my screen now, class?
Yes.
Yes.
Okay. So I want everybody to go to webassign.net. or webersign.com. It's going to bring you to the same place. If you're doing it on a computer, your screen will look like this. If you're doing it on the phone, you will not see the enter class key. So for those who are on the computer, let me explain. I want you to hit this gray button that says enter class key. Once you hit that gray button that says enter class key, this is the class key. And I'm going to make it a bit larger. bmcc.cuny 84794799. bmcc.cuny 84794799. Can everybody see that?
Yes.
Yeah.
Okay, those of you that are on a mobile device, once you're on that WebAssign page, like I suggested, above the sign in, there are going to be 3 lines. You're going to click on those 3 lines. Then you're going to click on the student tab. Once you click on the student tab, the 4th option says, I have a class key, or it says something about a class key. That's what I want you to click on. Click on the option that says class key. Then you're going to be brought to this page, and then you can type in the class key. So I want to make sure that everybody gets an opportunity to enroll today. I actually came by your class originally on July 1st, but I didn't have access. So I'm thankful to Professor Lee for granting me access.
Totally.
Is everybody with me?
Yes.
Once you enter the class key, I want everybody to hit enroll. When you hit enroll, what you're going to see is a picture of a textbook. Then you're going to see Immersion 56, Math 56, Immersion 2. You'll see my name, Dr. Dawes. And then I want you to hit continue. When you hit continue, it's going to tell you to log in. However, that assumes that you have a login or a username for WebAssign. Most of you do not. In that scenario, what you need to do is click on this button on the bottom that says create account. One moment, class. Click on the button on the bottom that says create account. When it's asking you to create an account, you're going to confirm that you're a student. Now, here is where you're going to provide your primary email address. Your primary email address. If your primary email address is your BMCC email address, then fine. Use that one. But if your primary email address is a Gmail or Yahoo or whatever email address you're using, I want you to use the one that you actually check. All right? Now, once you put in your primary email address, you're going to get in, and you're going to have to start registering.
Mr. I have a question. I'm sorry.
One moment. Let me finish. You're going to start registering. When you register, it's going to ask you for your year of birth, not your date of birth, your year of birth. So if you were born in 2002, you just put 2002. Okay, we don't need the month or the day. It's also going to ask you for your time zone. BMCC is located in the Eastern Daylight Time Zone, EDT. On WebAssign, you're going to see Eastern, and then it's going to say USA and Canada. That's the one that you can pick. I think it says GMT at the end. Okay? Eastern Daylight Time Zone. In addition to that, later on in the process, it's going to ask you for your student ID number. When it asks you for your student ID number, it just means your CUNY First ID or the number that's on your BMCC physical ID. That's all it's asking you for. Also, what you're going to need to do is it's going to ask for an activation code. That's going to be sent to your email address. You do not have to copy the code from your email address and then put it into whatever device you're using. You can simply click on the link on your email inside that email that's sent to you. That's sent to your primary email address. and then it will allow you to create a password. I believe it has to be 8 characters minimum. Now, Takeda, I believe you had a question. What's your question?
I'm so sorry. Like my network was dropped. I didn't hear like where I have to go. I was trying to reconnect, but I can't. Sorry. Can you tell me again, please?
Sakita, what we can do is we can wait till the end and I can make sure that you have access. Is that clear? However, Professor Lee sent you an email a few days ago. And in that email, there was a link. And that link brings you, and I'll show you where. That link brings you to a page like this. And then from there, you can enroll. Now, I promise that I'm not going to run away. I promise I'm going to make sure that everybody has access to the system, and anybody that's having any technical difficulties or having any issues logging on, I promise I'll be here to help. However, right now, what I want to do is I actually want to show you what resources we have created for you. So anybody else that needs help registering, just wait until the end after I show you the resources, and I promise I'll be here to help. Is that clear to everyone?
Yes.
Yes.
Thank you for responding, Mike. I appreciate it. Okay, thank you. So class, you actually go into WebAssign, and this is after you've registered and you click open WebAssign. I'm going to show you a couple of things that you're going to see. I'm going to focus on 4 assignments first. The first assignment I'm going to focus on is the Math 56 final exam. All right. Now, how many of you have actually successfully registered?
I just registered right now, but I don't see the same.
Okay,
As
this
what
is what I
you're
want you
looking
to do. I'm going to stop sharing. I want you to share your screen. Is there anybody on a computer that just registered? If so, I want you to share your screen. And I'm going to show your classmates what they need to do. In order to share your screen, there's a green arrow. There's a green button on the bottom. Okay,
Yeah,
great.
Michael, yeah.
Michael, I want you to click Open WebAssign. Now it's going to ask you for your student ID number. All right, now you can stop sharing your screen so you can privately type your student ID number in. Everybody with me? Okay. Michael, once you've typed your student ID number in, I'd like you to share your screen again. Okay. Now Michael is in WebAssign. All right. So I'm going to show you a couple of things from my perspective and a couple of things from Michael's perspective. All right. Now, Michael, I'm going to, you can stop sharing right now. I'm going to start sharing again, but thank you for your help. That's what everybody should have access to.
Yes. Thanks, Michael.
No problem. Okay. Was everybody else able to successfully register?
Yes.
All right, wonderful. All right, now I'm going to share my screen with you. Okay, so the first assignment that I'm going to focus on is your final examination. This is an online class, so your final examination will be online. It's going to be through this system. Your final examination is going to be on July 25th. Starts at, I believe, 9:30 a.m. and ends at 12:30 p.m. Am I correct, Professor Lee?
Yeah, I think so, but I'm not 100% sure because I have to
Okay.
double check, but I believe that should be the time. in the past. I did it once in
Okay.
person, you know.
So there's a
Yeah,
couple of things that I want to point out to everybody. For your final examination, you will have 1 hour and 45 minutes. You don't necessarily need the whole time. For the students just like you that have taken this test in the past, it's taken them about between 1 hour and 10 minutes and 1 hour and 20 minutes. This is assuming that you take the time to study, okay? I've given you additional time just in case you have any kind of technical difficulties. Your class ends at 12:30. Your exam will probably start around 10:30 a.m. in the morning. This is how it's gonna work. I'm gonna send you an email. Your professor is gonna be carbon copied on that email. In that email, you're gonna have instructions for the examination, and you're gonna also see the password to the examination, all right? I'm probably gonna send that email from early in the morning, meaning you might even have the password at 8 a.m. However, the password will not work until 10:30 a.m. Okay? So what you're going to do is you're going to still come to class with Professor Lee, and you're going to review before you take that examination.
Yep.
At around 10 o'clock, I'm going to have a Zoom meeting. And in that Zoom meeting, I'm going to be answering questions for anyone that's having difficulty accessing the final. But if you listen to me today, you should have no difficulty accessing the final. But I'm aware that some people are not going to listen, and on the day of the final, they're going to have questions. I'm going to be available to answer those questions. Your final exam has anywhere between 20 and 22 questions on it. Okay? It is password protected, as I discussed. You're going to have to download something called Lockdown Browser. I'm going to show you that right now. And before you can actually access this assignment, you're going to be required to finish a previous assignment. One other required assignment on here. Can somebody read that message for me?
Yeah. It says you must achieve 10% or higher on trial and math 56 final underscore lockdown browser underscore file. Upload the access to access this assignment.
Thank you, Michael. So there's this previous assignment here. This assignment, the trial math 56 lockdown browser file upload. Weird name, but this assignment does a few things. It shows you how to enter a password into WebAssign. It shows you how to access Lockdown Browser. It gives you experience with a timed assignment, okay? Now, notice I said that you only need a 10%. I'm actually gonna drop that down to a 5%. You only need a 5% on this assignment. Meaning, as long as you can get one question correct on this assignment, you will be able to access the final examination. I don't need you to complete the assignment. I simply need you to answer one question correctly. The goal is to make sure everything surrounding it and what you know what the testing environment feels like. Now, I'm going to actually show you what it looks like. Give me one moment. And I'm going to show you what it looks like from the instructor's perspective. Now, I am not concerned. I'm not concerned with you actually seeing the answers. I'm more concerned with you understanding how this works. And after this, I'm going to show you some practice exams, 2 practice exams, and some assignments that might help you. Okay. So I'm going to share my screen again, and I'm going to show you what the assignment looks like from the instructor perspective. Okay. So this is what the assignment looks like from the instructor perspective. I'm really not concerned with you seeing the answers because you're going to have different versions of the test. The first question is just graphing systems of equations and then finding the solution. Second one, translating a sentence. The third one, another system of equations. This question, the fourth question, is what I want to point out. This is what's important. This isn't file upload question. All right. There's a free app called Cam Scanner. You do not have to pay for it. There's a paid version. You do not need it. Only use the free version. There's an equivalent app called Genius Scan. And what this app allows you to do is to take multiple pictures of your handwritten work and put them together in one file, one PDF file. And then what you do is you upload it in WebAssign. Now, why do you need to know how to do this? On your examination, when you submit it on WebAssign, you're going to get a preliminary grade. Now, even though you get a preliminary grade, that's not your final grade. What I'm doing is I'm giving you an opportunity to get partial credit. How do you get partial credit? By uploading your handwritten work. And your professor, Professor Lee, will be able to look at your handwritten work and give you credit. So that can take a grade, a preliminary grade that was 52 to a 72. From something that was failing to something now that is passing. This is a great opportunity for you, but you need to practice doing it. And Professor Lee may also ask you to upload your PDF into Brightspace. When you're uploading your PDF, you need to number the questions properly. You need to write legibly. Make it as easy as possible for Professor Lee to be able to see your work. Now, inside this question, the first video, it is a video about how to use Cam Scanner on an Android device. The second video is a video about how to use Cam Scanner on a Apple or a Mac device. All right? Remember, all you have to do is get one question correct. That means if you successfully upload a file here, that's sufficient. And that's the one question that you've gotten correct. On the day of the examination, let's say that you have finished the examination and you can't connect your phone or your tablet to your computer using your charging device. You can simply email your PDF from Cam Scanner to yourself and down your computer. However, you're going to have to exit Lockdown Browser in order to do that. And I'm going to explain all of that to you. Any questions on that?
Is there something that
Anybody?
I'm sorry.
Go ahead.
Is there something that needs to be done before like even the exam starts? So like
Yes, it
earlier
is.
than
It does need to
9:30
be
or
done before
10:30?
it does need to be done before the exam starts. So let me explain. You have access to this from today. You do not have to wait to attempt this. I'm going to click on it. Once I click on this assignment, a couple of things. You have Lockdown Browser Help. I'm going to click on Lockdown Browser Help. This is where you can download Lockdown Browser. If you're using a personal computer or a PC, you download the Windows file. If you're using an Apple computer or the Mac operating system, you download the Mac file that's appropriate for your computer. This cannot be done on a phone. This cannot be done on a tablet. This must be done on a full computer. So it shouldn't also be done on a Chromebook. However, if you are using a Chromebook and that is your only device, reach out to me and I will give you the link that you need in order to access Lockdown Browser on a Chromebook. So all I did was I went to the assignment and I clicked on that first link that said Lockdown Browser Help. Now I will be sending an email about this, including the links that you need to get the information that you need. For this one, I said there's a password. The password is test prep 1. Capital T, capital P, the number 1 at the end. There are no spaces. Test prep 1. I'll type it here. Test prep 1. That's the password. And I'll send out email reminders to you as well. You could do that today if you wanted to. However, remember, it is a timed assignment. So until you're ready to actually sit down and do it, don't start it. Now, hopefully you'll get it done early, but everybody won't get it done early. Some of you are going to wait till the day of the actual examination. Your classmates are going to start the test and you're going to wonder why you can't start. And the reason that you can't start is because you didn't finish this assignment. And remember I said that I was going to change it to 5%? I did change it to 5%. I just need to refresh the page. All I need you to do is get one question right. Now, there are 3 other assignments that I'm going to show you that can be extremely helpful for you. I've given you, and actually before I move off from the exam itself, let's say you have any issues uploading into this trial assignment. For any reason, there's a second assignment that opens up and it has literally one question, that same upload question that I showed you. And you get an additional 20 minutes simply to upload a file. This is the same thing that occurs on the examination. Let's say you need that entire time for the examination. That's fine, you can use it. After you submitted the examination, this assignment opens up and you get an additional 20 minutes just to upload your file. That's how it works. Now, 2 things, 3 more assignments that I want to show you. 2 more assignments I want to show you. I've given you these practice exams. There's a practice exam without help. This practice exam without help. In order for you to get any feedback, you have to submit the entire assignment. You cannot submit one question at a time. Now, my suggestion is that you do this assignment first. Why? When you do it first, I don't want you to be concerned about the grade that you get. I want you to be able to quickly identify, what do I know and what do I still need to work on? And once you've identified what you need to work on, you can attack it. Now, how can you attack it? Your first line of help is your professor. He knows the content that's going to be on the examination, and he can answer your questions. But by doing this practice test first, and this practice test is longer than the actual test. Remember, the actual test is 22 questions max. This practice test has 33 questions. So it's not the exact same thing. But when you do this first, what's going to happen is you're going to be able to see, okay, I need to pay attention for these questions. So when Professor Lee is going over it during class, what you're going to recognize is, okay, I have a heightened level of attention and I ask better questions. You're going to be, sorry about that, you're going to be able to do this multiple times. So don't be concerned about your grades. Again, you only get feedback when you hit submit assignment. And then, well, I guess I did not do that on purpose. But in order to redo the assignment, what you need to do is you need to click on new randomization. And that's going to give you a whole new version of this assignment. Does that make sense, class?
Yes.
Yes.
Yeah.
Now there's another test other than your professor. What can you do to help you? There's another practice test. This practice test has help. It says Math 56 Cumulative Practice Final with help. In this practice test, you're allowed to submit questions one at a time. In this practice test, there are different resources that are going to be there to help you. So let's say I think that the answer is x to the third, and I'm going to be wrong. Notice I'm allowed to submit answers one at a time. But not only am I allowed to submit answers one at a time, I see it from right or wrong. I see a solution on how to do it step by step. And I have this gray button that says new randomization. So this allows me to redo that problem over and over and over again. Is this something that can be helpful to you while you're studying for your examination?
Yes.
Yes.
I'm glad to hear it. The students that actually use the practice examinations to study in the way that I'm telling you how to use it, they do very well on this examination. And that's why I created them for you. I want you to do well. There's only 2 other assignments that I'll show you. There's this college math readiness boot camp. Now, this is not a required assignment, but I want to point out to you how this can help you. Now, let's say you have an issue with dividing rational expressions. Your real issue might be with dividing fractions. And let's say I think that the answer is 5. So I'm going to hit submit answer on dividing fractions. I'm going to be wrong, but I want to point out the feedback that you get. So now that I'm wrong, I get something called a learn it. And if I click on this learn it, it's going to give me a scaffolded approach in order to understand the concept. A short reading about multiplying and dividing fractions. A lecture video about multiplying and dividing fractions. A step-by-step tutorial that I can work on about this concept. And it allows me to have practice problems that I can work on. But the most important thing that you're given right here is this. These learners are connected to other learners. So maybe your issue is really not multiplying and dividing fractions. Maybe you know how to do that, which you need in rational expressions. Maybe your issue is simplifying fractions. And if you click on that learn it, it gives you a whole nother set of information about how do we simplify fractions. This assignment is called College Math Readiness Bootcamp. There are tons of questions on this assignment. Or you do not have to do the entire assignment. It is not required. All you need to do is find the concept that you're struggling with. Maybe with radicals, okay? Maybe with fractions, maybe with order of operations. Find a concept that you're struggling with. Attempt it. If you get it wrong, access to learn it. That's what it's there for. Is this something that can be helpful to you, class?
Yes.
Yes.
All right. So the last things that I will show you is this. I've given you these 2 assignments, exponentials and logs and trig word problems. They are not required either. But the reason that I'm highlighting these assignments, because in Math 56, these tend to be the last topics. And sometimes because it's the last topic, students are not paying attention with the level of rigor that they need to. So I'm highlighting that you need to know these kind of things. For example, for this trig word problem assignment, it has a video embedded. It starts off with some simple questions, helping you understand the language that's going to be used. And then it gives you some actual trig word problems for you to work on, for you to do. And you can even upload your work. It gives you videos related to it. But what I want to point out that I gave you is this. Not only did I give you those assignments for you to practice, and I'm telling you, there will be 1 trig word problem on your examination. And that trig word problem will probably look like one of the questions in that assignment. What I want to point out to you, this is the last part. I want you to click on resources. Under resources, I have a lot of things. I have some PowerPoints about factoring, because that's a subject that students tend to struggle with. I have a paper practice examination that you can work with. This is something that you would find in the math lab. But what I want to point out to you right now is this. Not only did I give you those assignments, I've given you handwritten solutions. You can tell it's handwritten because it's ugly, but I promise you, if you look at it, you will learn how to do this. All right? So for all of the problems in there, the word problems, I've given you handwritten solutions. For that other assignment, exponential and logs in class, I've given you handwritten solutions. And in order to access this, all you need to do is scroll down to the bottom left and click on resources. And the ones that I have just showed you have solution in their name. Underneath that, for any chapter in any section of the book, you just need to click on it and you have a lecture video. And you don't just have 1 lecture video. You have multiple lecture videos. All right? And it's not just a few. It's many with different voices about different topics. All of that is under resources. Now, class, can this be helpful to you?
Yes.
Yes.
Well, I want to thank you for your time. And again, I'm not running away. I'm still here to answer any questions. For those of you that have questions, they can email me here. That's my email address on the top. This is the fastest way to communicate with me. Or inside WebAssign, you can click on communication. Once you click on communication, just hit new message and you can send me a message there as well. Now, does anybody have any additional questions for me?
What
Whether
about the
you
browser lock?
logging on,
Mister,
about
I
the browser
have a
lock?
question.
hold on, give me 1 second. I heard Demir first and then Skidder. Go ahead, Demir.
What about the browser lock that you were talking about?
The lockdown browser.
Yeah,
Okay. Did you register already?
not yet. Oh yeah, I registered for the web
Are
assign.
you on a
Yeah, I did.
computer?
Yeah.
Can you share your screen? I'll show you exactly how to access it.
All right.
Skidder, and if I'm mispronouncing your name, please feel free to correct me. Okay, so there's a trial assignment. It says trial, that one, click on it. You see the first link that says lockdown browser help? Click on it. Scroll down. Do you have a PC or a Mac?
I have a Mac.
So as long as that's your operating system, that's what you download and install.
Okay.
All right?
All right, I got it.
Great. You can stop sharing. Skidder, go ahead.
Mister, when you was beginning with the website, my network was dropped. That's why I
So I
cannot.
remember what you said. I heard you.
Yeah.
As I told you, I'm here to help. So
Yeah, yeah.
for those of you, if you don't have any questions, you can feel free to go. Professor Lee, is there anything for the students that are ready to leave? Is there any last thing that you want to say to them?
No, not at all. But yeah, I see you guys tomorrow then. Okay, if you have no
Okay.
questions. All right.
Now, for Skidder, what we do is you go to webassign.net or webassign.com. The page should look like this. Are you on a phone or are you on a computer?
I'm on my phone. My computer is not running right now.
Okay, so you don't see this gray button that says enter class key. You can try to turn your phone horizontally and some phones will show it. But since you don't see it, there are these 3 buttons on the above sign in. I want you to click on that. Once you click on those 3 buttons, go onto the tab that says student. Under student, what I want you to do is go to the place that says I have a class key. I have a class key. Are you there?
Yeah, out there. Yeah.
Okay. Now, for the class key, what you're going to be doing is you're going to be putting in this number.
What's the number?
Give me a second.
Sorry.
Professor Lee actually emailed this to you a few days ago.
But I didn't get any email from him.
Oh, okay. It's okay, Skidder. If you didn't get any email, make sure that it's not going to spam and that you're using the appropriate email address. This is the class key.
I checked today morning.
One thing you can do is make sure that you talk to Professor Lee about what email you're using. And then we can go and take a look at your spam to make sure it didn't go to your spam messages. But it's important that you're getting emails from your professor. And later on, you're going to be getting emails from me. And I want to make sure that you get them. Now, this is the code, bmcc.cuny 84794799. You see it?
8479. Can you say it again?
No, look at the screen. Can you see the screen?
No, I don't see your screen.
I want you to look at the screen for a second so you can see how it's written.
Okay.
You don't see it at all? Give me 1 second, sir. That's not on you. That's on me.
Okay.
I should have shared my screen. Can you see it now?
Yeah, I can see it now.
My apologies. It's
No problem.
bmcc.cuny 84794799. It doesn't matter if you type it with the spaces or without the spaces. It will work either way.
Yeah, I get yes, they are showing like welcome.
Yes. Now you hit enroll. Once you hit enroll, you're going to have to create an account.
It's showing a continue button, then I enroll, right?
Hit continue. After enroll, you're going to hit continue. And it's going to ask you if you're a student. You're going to say yes.
No, it doesn't show me to enroll button. It just show me to continue. Then I click on continue. Then just showing me the sign in and the putting my
Okay,
username.
so let me explain. When it's asking you to sign in, this is what you see. Can you see my screen?
Yeah, I can see your screen.
You need to click on this button that says create account. Do
Yeah.
you see
So
it?
yeah.
So you're gonna click create an account. Now it's asking you if you're a student.
It doesn't showing me any create account. Just showing me to sign in.
Look at my screen. Look at my screen.
Yeah.
Can you see my screen?
Yeah, I can see it.
It is asking me to do the same thing it's asking you to do, to put
Yeah.
in a username. However, I'm gonna pretend to be you. I don't have a username yet. So you see on the bottom, it says create account. There's a link that says create account.
Yeah.
I want you to click on that link. The link that says create account.
But I didn't see any link here for create account.
Can you see my screen, Cedar?
Yeah, I can see your screen.
Okay, I'm gonna draw something on the screen right now. You see the ellipse, the circular looking object that I just drew?
Yeah,
On the
I
bottom
can
in
see on your
red?
screen, but in my phone I can see the option. That's what I'm
I
saying.
need you to scroll down and it should give you an option that says create account.
Yeah, I see it. Yeah.
Click create account.
Yeah. Then are you a student? Yes.
Yes.
Then I put my email, right?
Your primary email address, the one that you check on a regular basis. If that's your BMC email address, that's fine. But if you're using a Gmail or something else, that's what you put in there.
Yeah, I put my email, then it's showing for my name and the birth year, right?
You're going to put in your information, your personal information, your name, your address, the year that you are born. When it
Okay.
asks for the time zone, you're going to be putting in Eastern. It's going to say US and Canada. Is that correct, class? Is that what you saw?
Yeah, I saw like wait a minute, like
It was
East-
all
I'm asking your
GMT.
classmates.
It
Go
was
ahead.
all GMT. It was all
Yeah,
GMT, and then
we saw GMT.
for the Eastern time, just search up US and Canada. It should be there. It should be Eastern time, US and Canada.
Thank you.
Yeah, GMT 7 Mountain Time, US and Canada.
Listen,
that one?
no,
It
you
should
need
it should be
you East
GMT minus
Eastern.
5. GMT minus 5, that's the one it was.
Thank
Yeah,
you,
I got
Demeter.
it. Eastern time. Yeah, I got it.
When you finish that, it's going to send you an email, and it's gonna in the email there's gonna be an access code. In the email, you're gonna click on the link, and then that's gonna allow you to create a password.
Okay. I just copy paste the link.
No, don't
Activate.
copy and paste it. Just click on it. Now, while Skidder is doing this class, does anybody else have any other questions for me?
Excuse me, I just go to the restroom right now, and if we don't have any questions, can we
Yes,
Yes, you
I
can go.
said that
Yes.
a few minutes ago.
Yes.
If you have
Oh,
any,
okay,
if you
thank
don't have
you.
any questions, you can feel free to go.
Mhm.
Thank you, Mr. Dawes.
You're welcome, Michael. I'm here to help you. We want you to pass. For
Yeah,
those, anybody else that doesn't have a question, just have a great day. Remember, we're here to help you. We want you to do well.
Thank you.
Question, I'm sorry. It's just a quick one, real quick. So with the practice exam that you're saying, um, we can like, can we start doing those, or like, would you
Absolutely.
recommend?
I would
Okay.
recommend you start doing them. At least try this one first. You're not going to be
Okay.
able to answer all of the questions yet, and that's okay. The point of doing it, trying it first, is you need to know which questions you can't answer, and then we attack them. Does that make sense?
Yes, sir. Thank you so much.
Mister, I create my username and the password.
Yes. Now you should be able to log in.
Yeah, I can log in and it's showing like open website view.
Click on open
ebook.
website, and then you're going to get something that asks you for your student ID. That is going to be your CUNY First student ID or the number that's on your BMCC ID card.
Oh, okay. Hold on. 2, 4, 5, 8. Yeah, I got it.
All right. Then you'll be able to see everything that's inside.
It's
For
showing
your
my
time. Go
assignment.
ahead, Skidder. Go
I
ahead.
show it's showing my assignment like math, growth, college math. Like it's showing many assignment. Yeah, I can see it.
Yes, but remember the ones that I told you that you should do.
Yeah.
Is that clear?
I don't need to do all of them, right?
No. Remember what I told you. This one is required. And I gave you
Okay.
the password, test prep 1.
Yeah. This is the
Once
password
you
for
get
the
5% on this assignment, you will be able to access the exam on the 25th. You do not have to wait to do that assignment. You can do it earlier rather than later.
Oh, okay. So I'm supposed to do this at least 5% with the password that you give me, then I will be get access for the exam, right?
That's correct. But remember,
Only one assignment, right? Only one assignment I have
this
to
is
do,
the
right?
only, listen to me, Skidder. This is the only required assignment, and then the final is also required. You need to do both. Is that clear?
Yeah, I got it.
But other than the final exam, which you know you have to do, this trial assignment is required because it makes you comfortable with the system. So do you see how you were having some trouble logging in and I helped you?
Yes, yes.
During the final examination, if you have any issues, I will be here to help you as well. But I want to
Okay.
prevent you from having issues. That's what this assignment will do for you. If you just practice it and simply get one question right, then it will be easier when you're taking the final.
Okay, I got it, sir.
One other thing, you need to work on the practice test, Skidder. I'm not making them a requirement, but they're highly suggested.
Okay, that will be helpful for my exam, right?
Yes.
Okay.
Any other questions?
No, I'm good. I'm gonna practice it and I'm gonna submit the trial assignment and then I can get the access for the final. I got everything. Thank you
That's
very
right.
much.
Professor Lee, is there anything else?
No, Dr. Dawson, it's all good. Thank you. Thank you.
Thank you, and I'm sorry for holding you late. I should have just let you make me host so I can answer the final questions.
Yeah, that's great. Yes. Sounds good.
Okay.
All right.
Okay,
so-
my friend. I'll talk to you shortly.
I'll talk to you now. Okay.
Take care.
All
Bye.
right. Bye-bye.